Welcome to Saveetha Dental College Lecturecast in Biostatistics. Today's class is on Descriptive Statistics. The five major topics in this class include mean, median, mode, variance, and standard deviation. First, let's look into the mean. Mean is represented by x bar, and it is the sum of all the values in a group by the number of values in the group. For example, in this group we have 6 values and their sum totals to 36. So when you divide 36 by 6, your mean is 6. Median is a middle value in any group. But the first step to determine median would be to rearrange the group in either ascending or descending order. For example, in this data set where we have 1, 7, 5, 3, 9 and 11, to determine the median, we will have to rearrange them as 1, 3, 5, 7, 9 and 11 and determine the midpoint. Since there is no one value which falls in the middle of the group, we take the average of the two. If we had 7 values in this group, the fourth value would automatically become the median. Next, let us look at the relationship between mean and median. If the mean and median are very close to one another, it means that the data is evenly distributed. But if there is a significant difference between the mean and the median within a group, it means that the data is not evenly distributed. For example, in the following data set, we have 1, 3, 5, 7, 9 and 110. When you take the mean, it is 135 by 6, which is 22.5. However, the median still remains at 5 plus 7 by 6, that's a middle value, as 6. 7 by 2, However, the median remains at 6 because it is the average of the two middle values, which is 5 plus 7 by 2 equals to 6. So since there is a significant difference between the mean and the median, it means that there is one or two values which are really abnormally high in the data set. That is what is creating the shift in the mean. Mode is the highest frequency of any data point within a data set. So each value would be a data point, and whichever data point has the most common occurrence, that would be the mode for the group. So in this group, 3 occurs 4 times, and so the mode of this data group is 3. Next, let us look into variance. Variance is the range or variability of data from the mean. In this data set, we have 1, 3, 5, 7, 9 and 11, and our mean is 6 as we calculated before. So the variance would be how much does each value vary from the mean. So 1 minus 6 would be minus 5, 3 minus 6 is minus 3, 5 minus 6 is minus 1, 7 minus 6 is plus 1, 9 minus 6 is plus 3, and 11 minus 6 is plus 5. However, if you add all these values, you would get a variance of 0. To avoid this kind of an error where the minuses and the pluses cancel out each other, we multiply them by themselves, or we make a square of them. So when you add the sum of squares, you get 25 plus 9 plus 1 plus 1 plus 9 plus 25. So it's 70 by 6. So the variance of this group is 11.667. Standard deviation is the square root of variance. We know that the variance was calculated based on the square of the variations we observed. So to bring back to the original values, we take a square root, and that is our standard deviation. So in this case, the standard deviation is 11.667 and square root of 11.667, and that is 3.41. So when you describe a group, we normally say the group mean and standard deviation is 6 plus or minus 3.14. So if the standard deviation is very wide, it means that the variability is also very wide, and that the numbers are much higher and lower than the mean. When we learn about standard deviation, and another important statistical concept to be covered would be the central limit theorem. This is useful to predict cutoff values based on the mean and standard deviation of any group. However, the central limit theorem is only applicable to normal distribution. A normal distribution is a group in which all the values are evenly distributed above and below the mean, meaning there is no outlier in the data. Whereas a non-normal distribution would be such that the data is not symmetrically distributed around the mean. According to the central limit theorem, in a normal distribution, 68% of all observed data would lie within one standard deviation of the mean, 95% of all observed data will lie within two standard deviations of the mean, and 99.6% of all the data would lie within three standard deviations of the mean. So if you look here in a bell curve and you have the mean here and your standard deviation is drawn arbitrarily here, you can say that within these 2 points, 68% of all your values will lie. Within these 2 points, you'd have 95% of the values, and within these 2 points, you'd have 99% of the values. So, for example, if the mean or IQ of a population is 100 and the standard deviation is 15, we can say 68% of the people in the world will have an IQ of 85 to 115, and 95% of the people will have an IQ of 70 to IQ between 70 and 130. So in this context, if you have an IQ more than 130, you can say you are above the 95% of the population. But you should remember that we are only looking at this end, whereas this end will be another 2.5% on either side. So actually, if your IQ is more than 130, you mean that it is 98% of the population. Further details on calculating cutoff values for any normal distribution will be discussed in advanced classes. And that concludes our class for descriptive statistics. Thank you.